Okay, today we are going to the next module, that is module 2. Before going to module 2, we want some topics from the module 1 whose continuation is the module 2. Okay, that is recall. A scalar field is a function that gives us a single value of some variable for every point in space. Example, voltage, current, energy, temperature. That is, a scalar quantity is a physical quantity which has only magnitude, no direction. Okay, then second point, a vector quantity is a quantity, physical quantity, which has both magnitude and a direction in space, whose example velocity, momentum, acceleration and force. Okay, we already discussed what is vector and vector addition, subtraction, scalar multiplication, vector multiplication, gradient of a function, etc., etc., etc. in module 1. Okay, the gradient of a scalar function creates a vector field. Gradient of f equal to del f equal to fx I cap plus fy j cap plus fz k cap, where the operator del equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Okay, then dot product, cross product. Dot product is the product between two vectors whose result is a scalar. Then dot product is called a scalar product, and cross product, which is the product of two vectors, the product gives as a vector quantity, then cross product is called vector product. Then derivation of vector valued function, integration of vector valued function, and limit continuity, this all we already discussed in first module. Okay. The first topic in this module, that is curl and divergence. Okay, before that, we want a vector field, that is, let capital F or vector F be a vector field. What do you mean by a vector field? In vector field, every point in a vector field have some direction. Look this picture. Suppose this is the page of our book. Then take any point on that which has some direction. Okay, that is, let F be a vector field. Every point in a vector field has some direction. Okay, then divergence. What do you mean by divergence? Divergence is the divergence of a vector field simply measures how much the flow is expanding at a given point. That is, the tendency of a vector to disperse or converge or collect, or we say that converges to a point or converges from a point. That is divergence. നമ്മൾ എന്താ മീൻസ് ചെയ്യുന്നത്? ഡൈവേർജൻസ് എന്ന് പറഞ്ഞാൽ ഈ പിക്ചറിലേക്ക് നോക്കാം. ഇതെന്താണ് നമ്മൾ പറഞ്ഞു? ഡൈവേർജൻസ് എന്ന് പറഞ്ഞാൽ ഇറ്റ് ഈസ് ദ ടെൻഡൻസി ഓഫ് എ വെക്റ്റർ ടു ഡിസ്പേഴ്സ് ഓർ കൺവേർജ്. പറഞ്ഞാൽ ഒരു പോയിന്റിൽ നിന്ന് എല്ലാ വെക്റ്റേഴ്സും ഡിസ്പേഴ്സ് ചെയ്ത് പോവുക, അല്ലെങ്കിൽ ഒരു പോയിന്റിലേക്കെല്ലാം ഒന്ന് കളക്ട് ചെയ്യുക, അല്ലെങ്കിൽ കൺവേർജ് ചെയ്യുക. ഈ രണ്ട് ഫിഗേഴ്സും ശ്രദ്ധിച്ചാൽ നിങ്ങൾക്ക് മനസ്സിലാക്കാൻ പറ്റും. ഇൻ ഫസ്റ്റ് ഫിഗർ വിച്ച് ഈസ് ദി ഡിസ്പേഴ്സ് ഓഫ് വെക്റ്റേഴ്സ്, ആൻഡ് സെക്കൻഡ് ഫിഗർ ഇസ് ദ കൺവേർജസ് ഓർ കളക്ട് അറ്റ് എ പോയിന്റ്. ഓക്കെ, ദാറ്റ് ഈസ് divergence is the convergence of vectors to a point or converges from a point. Okay, then it does not indicate in which direction the expansion is occurring. Therefore, the divergence is a scalar. That is, നമ്മൾ പറഞ്ഞു scalar quantity എന്ന് പറഞ്ഞാൽ we know that scalar quantity has only magnitude. Then divergence of a vector or two vectors or multiple vectors, which is the tendency of a vector to disperse or converges, which does not indicate which direction or which has only magnitude, then the divergence is a scalar quantity. Next we move to the derivation of scalar quantity, divergence. What is mean by a divergence? Okay, let f equal to f1 I cap plus f2 j cap plus f3 k cap be a vector valued function. Then the divergence of capital F or vector F equal to divergence of F, that's equal to del dot F. Okay, that is the dot product of del and the vector capital F. That is, we know del means gradient operator, and F is the given vector valued function taking whose dot product. Del is a vector and vector valued function which is also a vector, then taking the dot product which gives a scalar, that is del dot F equal to dou by dou x f1 plus dou by dou y f2 plus dou by dou z f3, which is a scalar quantity. Next, if del dot f equal to 0, that is the divergence of that function f equal to 0, then f is said to be divergence free, which has no divergence. Then together we look for this topic, source and sink. What do you mean by a source and sink of a vector valued function? Let f of x, y, z be a vector field in space, then a point x, y, z is a source if del dot f greater than 0. A point x, y, z is a sink, then del dot f is less than 0. That is, when we calculating the divergence, that is del dot f, whose value at a point x, y, z is greater than 0, that is positive, then we call f at that point is source. Okay, then the del dot f, that is divergence of that vector field function which is less than 0, that is negative value at the point x, y, z, then which is called sink. Next, if del dot f equal to 0, then source and sink does not exist. That is del dot f, that is divergence of that function equal to 0, then we say that free of source and sink. Okay. Then next one, curl of a vector valued function. The curl is a vector operator. Listen, curl is a vector. Then what is divergence is a scalar. Then curl is a vector operator that describes the infinitesimal rotation of a vector in 3 dimensions. That is rotation of a vector field. That is curl discussing the rotation of vector in 3 dimensions. That is, the direction of the curl is in the axis of rotation and the magnitude is the magnitude of the rotation. Or we say that it is the tendency of the vector to shrink. That is rotate around a point. Okay, that is, it is the tendency of a vector to shrink. Look for these pictures, that is, which is the anti-clockwise rotation, which is the clockwise rotation. These types of representation is the curl, which is the curl of that vector field. The each points in this surface which is rotating around a point. Okay, this like is called curl of that function, that is, which is the tendency of the vectors to shrink. Okay. Next, let f equal to f1 I cap plus f2 j cap plus f3 k cap be a vector valued function. Then the curl of the function f is curl f equal to del cross f, that is the cross product of the gradient vector and the given vector valued function. We know that the cross product is the determinant of I, j, k. Second row, dou by dou x into dou by dou y in dou by dou z, which are the components of the gradient. And the third row, f1, f2, f3, which are the components of the vector valued function f. Then curl f equal to del cross f, that's equal to taking the cross product, which gives a vector that is equal to dou by dou y f3 minus dou by dou z f2 I cap minus dou by dou x f3 minus dou by dou z f1 j cap plus dou by dou x f2 minus dou by dou y f1 into k cap. Okay, which is a vector quantity. Listen, curl is a vector quantity and divergence is a scalar quantity. Next point, if curl f, that is equal to del cross f, okay, which is equal to 0, then the f is called irrotational vector. Listen, when the curl equal to 0 is called the irrotational vector. If divergence f equal to 0, that is del dot f equal to 0, then the f is called solenoidal vector. That is divergence of a vector equal to 0, then which is called solenoidal vector. Listen. Okay. Then look, we move for question section. That is first question. Find the curl and divergence of f equal to x z cube I cap minus 2 x square y z j cap plus 2 y z raised to 4 k cap at 1 minus 1 1. Listen, we want to find the curl and divergence of this vector at the point 1 minus 1 1. Okay, that is given f equal to x z cube I cap minus 2 into x square y z j cap plus 2 y z raised to 4 k cap. We want to find the curl and divergence, that is del dot f and del cross f. Okay, then listen here, given the vector valued function, then f1 equal to xz cube, that is the coefficient of I, and the f2 equal to minus 2x square yz, and the f3 equal to 2yz raised to 4. Then divergence of f, that is del dot f equal to, we have the equation dou by dou x f1 plus dou by dou y f2 plus dou by dou z f3, which is the partial derivation of f1 with respect to x, then which is the partial derivation of f2 with respect to y plus partial derivation of f3 with respect to z. Then we get partial derivation of f1, that is z cube minus 2x square z plus 8y z cube. We want the value of divergence of f at the point 1 minus 1 1. Okay, then del dot f at the point 1 minus 1 1, substituting values 1 minus 1 1 for x y z respectively, then we get 1 minus 2 minus z, then after calculation we get minus 9, that is divergence of that function, vector function, at the point 1 minus 1 1 equal to minus 9. Then next we want to find the curl of f, that is del cross f equal to determinant I j k dou by dou x dou by dou y dou by dou z xz cube minus xz cube, then minus 2x square yz, then 2yz raised to 4. This is the f1, f2, f3. Then after calculation we get, substituting the value 1 minus 1 1 for x y z respectively, then we get 2 minus 2i cap plus 3j plus 4k cap, that's equal to 3j plus 4k. Okay, then we get the curl of that function, that is del cross f at 1 minus 1 1 equal to 3j plus 4k, which is a vector, and the divergence of that function f at the point 1 minus 1 1 equal to minus 9, which is a scalar quantity. Okay, next question, show that the given f is irrotational. Given f equal to sin y plus z I cap plus x into cos y minus z j cap plus x minus y k cap. Here it is not, listen here, sin y plus z, not sin of y plus z. Okay, that is given f equal to this, then we want to find f is irrotational. When a function gives irrotational, that is a vector is irrotational if whose curl equal to 0, that is we want to find del cross f which is equal to 0, then that function is irrotational. That is del cross f equal to determinant of I j k dou by dou x dou by dou y dou by dou z sin y plus z x cos y minus z x minus z. Okay, then we get minus 1 plus 1 I cap minus 1 minus 1 j cap plus cos y minus cos y k cap, that's equal to 0. We already know how to find the determinant. Okay, then del cross f equal to 0, then we say that f is irrotational. Okay, curl equal to 0, then that function is irrotational. Okay, next question, determine whether the vector field are free of source and sink. Listen, free of source and sink. When a function free of source and sink whose del dot f, that is whose determinant equal to 0. Question, determine the given vectors are free of source and sink, and if it is not, locate them. First question, f equal to y plus z I cap minus x z cube j cap plus x square sin y k cap. Second question, f equal to xy I cap minus 2 xy j cap plus y square k cap. Okay, we want to find or check the given vectors are free of source or sink. That is first question, f equal to y plus z I cap minus x z cube j cap plus x square sin y k cap. Then taking whose determinant or finding determinant of f, del dot f equal to dou by dou x y plus z, that is f1, dou by dou y of f2, that is minus x z cube plus dou by dou z of f3, that is x square sin y. Here x coordinates components is not present, then taking partial derivation with respect to x is 0. Here also y coefficients are not present, or here z terms are not present, then partial derivation with respect to z gives 0. That is 0 minus 0 plus 0, which is 0. That is which is free of source and sink. That is the first function, given vector function whose divergence equal to 0. Then we say that the given f is free of source and sink. Then second question, f equal to xy I cap minus 2 xy j cap plus y square k cap. We want to find whose divergence, that is del dot f equal to dou by dou x f1 equal to xy plus dou by dou y f2 here f2 equal to minus 2xy plus dou by dou z f3, here f3 equal to y square. Then taking partial derivation of xy with respect to x, this give y, then minus 2xy with respect to y gives minus 2x plus y square with respect to z gives 0. That's equal to y minus 2x. That is, divergence is not 0. Then we want to find when which gives free of source and sink, when it gives source and sink. Okay, divergence f equal to 0 when y equal to 2x, that is y minus 2x equal to 0 when y equal to 2x. On this line, which line, y equal to 2x, f is free of source and sink. Then divergence f less than 0 when y less than 2x, which gives sink. Okay, then divergence f greater than 0 when y greater than 2x, which gives source of that function. Okay, listen, I think all are catch these problems. Okay, thank you.